Okay, today we're going to be doing 3-digit by 3-digit. So we're going to stop doing the renaming. All our area models are going to be without renaming, and that will help out a little bit. So we're going to start with an area model over here. And on top, I'm going to put 273. Now going down, we're going to split this up, starting with our lowest digit, which is 6, 40, and 300. And we're going to do it this way because over on a standard algorithm, the first thing we would do, if we would over here, we would do 6 times 3, and we would get 18. And we can't put the 1 here because only one digit, so we would carry it up. Now we got to do 6 times 7 would be 42, and 1 is 43. Carry the 4. 6 times 2 is 12, and 4 is 16. So we end at 1,638. Now on the area model over here, the same thing. We have 6 times 3 is 18. Carry our 1. 6 times 7 is 42, and 1 is 43. Carry our 4. 6 times 2 is 12, and 4 is 16. So we had the same product. Now we're moving to 40 times, if you can see over here, 40 times 273. First thing we're going to do is we're going to put that 0 in here so we can get rid of this 0 on the outside. Now we're only dealing with 4 times 3, which is going to be 12. Carry our 1. 4 times 7 is 28, and 1 is 29. We carry our 2. 4 times 2 is 8, and 2 is 10. So we end up with 10,920. Over here, the way it looks the same way, just like with the area model, we're going to put our 0. For our placeholder number, we're going to go 4 times 3 is 12. Carry our 1. 4 times 7 is 28, and 1 is 29. Carry our 2. 4 times 2 is 8, and 2 is 10. So you've got 10,920, same product. Third one, we have 300 times 273. We're going to start off by putting our 2 placeholders so we can eliminate these 2 10s. Now we're doing 3 times 3 is 9. 3 times 7 is 21. We have to carry a 2. 3 times 2 is 6, and 2 is 8. Over at the standard algorithm, we're putting the 2 placeholders because we're multiplying by 300, but we're going to make it 3. 3 times 3 is 9. 3 times 7 is 21. Carry our 2. 3 times 2 is 6, and 2 is 8. We get 81,900. Same as our area model. Now we add them up. We have 8, 5, 99 is 18, and 6 is 24. Carry our 2. We have 1, 2, and 2 is 4. And 8 and 1 is 9. So we have 94,458. If you're using the area model, if you line them up properly here, you can add them up. 3 and 2 is 5. 6 and 9 is 15. And 9 would be 24. Here are 2. 2 and 1 is 3. And 8 is 11. Oh, what did I do here? 8, 5. Here's my 8. 5 is 15. 24. Here are my 2. It'll be 3 and 8, 3 and 4, and 8 and 1. See, I did not line up my place values very well, and I had a problem when I started adding them. Okay, so make sure when you put them in the area model, if you're going to do it that method, line them up by place values. I did good till I got to the bottom one, and then I had a problem. Okay, in question 2, we're going to be doing a 4-digit by a 2-digit. Now our area model we're going to be drawing is one without renaming, which means our top factor, which is 7,481, we are not going to break up our place value. Now we are going to break up our second place value, which the first one is 200. Now we have 90 and 0. Area models don't show 0, so I'm going to put 90 in here. That's a standard algorithm. We have 7,481 and we're multiplying that by 290. Now, as far as the error model goes over here, the first thing I would do is multiply 90 times 7,481. So I'm going to put my placeholder in there so I only have to worry about basic math facts. Now I have 9 times 1 is 9. 9 times 8 is 72. 9 times 4 is 36. And 7 would be 42. 9 times 7 is 63, and 4 would be 67. So we have now 672,290. Over on the standard algorithm way it would look, same way, we're going to use this 0 down here so that we can have a placeholder. We go to 9 times 1 is 9. 9 times 8 is 72, carry our 7. 9 times 4 is 36, and 7 would be 42, carry the 4. 9 times 7 would be 63, and 4 would be 67. And we end up with the same numbers. Now the next one is 200 times 7,481. Well, we're going to put 2 placeholders there first because it's 200. And now we're going to just use the basic math factor 2. 2 times 1 gives us 2. 2 times 8 gives us 16. We carry a 1. 2 times 4 is 8, and 1 is 9. And 2 times 7 gives us 14. So we end up with 1,496,200. Now let's see the standard algorithm. We have a 0 for this one, but we also have to put the 0 for the 90 also. So now we have 2 times 1 is 2. 2 times 8 is 16. Carry the 1. 2 times 4 is 8, and 1 is 9. 2 times 7 is 14. Exact same number. Now when we add them up, we end up with 0, 9, 4, 8, 16, carry 1, 11, and 2. So we ended up with 2,168,490. Let's see about the area model. We got 0. 9 and 0 is 9. 2 and 2 is 4. 2 plus 6 is 8. 7 plus 9 is 16. Carry our 1. 6 and 1 is 7. 4 is 11. Carry a 1. And we end up with 2. So we have 2,168,490. Same answer. Okay, now this problem is going to be a little different. We actually have a 3-digit times a 3-digit. And we have no 0 like we did on the last one. Since we have to show all the place values, the first one's going to be 426 on top. Now, the 3 place values are going to be broken up for 300, 50, and 7. The standard algorithm is going to be 426 times 357. Now over here in on the area model, we start off with 7. 7 times 6 would be 42. Carry the 4. 7 times 2 would be 14. And 4 would be 18. Carry 1. 7 times 4 would be 28. And 1 would be 29. Way you'd look in the standard algorithm, 7 times 6 is 42. Carry our 4. 7 times 2 is 14. And 4 would be 18. Carry our 1. 7 times 4 is 28. And 1 is 29. So we have the same product. Now the next problem would be 50 times 426. But we're going to put the 0 here so we can eliminate that and use our basic math facts. 5 times 6 gives us 30. Carry our 3. 5 times 2 is 10 and 3 is 13. Carry our 1. 5 times 4 is 21 is 21. What it looks like in the standard algorithm, we're going to sit there and put a placeholder for that first digit. Now it's 5 times 6, which is 30. 5 times 2 is 10, and 3 is 13. Carry our 1. 5 times 4 is 20, and 1 is 21. Same product. Our last one is 300 times 426, so we're going to put 2 placeholders, and we're going to take them off. Now we have 3 times 6 is 18. Carry our 1. Now we have 3 times 2 is 6, and 1 is 7. And 3 times 4 is 12. Now let's go to our standard algorithm. Same thing, we're going to have 2 placeholders this time. Now we're going 3 times 6 is 18. Carry our 1. 3 times 2 is 6, and 1 is 7. And 3 times 4 is 12. Same product. We add them up. We have 2, 8, 8, and 8 and 9 is 17, and 3 is 20. Carry our 2. 7, 2 is 9, 1 is 10, and 2 would be 12. Carry our 1. 2 and 2 is 4, and 1 is 5, and our 1. So we'd end up with 152,082. Over here, if we added it up, that'd be 2, 8, 8 and 7 is 14, and 3 is 20. Carry our 2. 2 and 2 is 4. 1 is 7. Excuse me. 7 and 1 is 8. 2 is 10. And 2 is 12. Almost got off again. 2 plus 2 is 4. 1 is 5. And our 1. So we ended up with 152,082. Our last problem is a word problem. It says a Hudson Valley Renegades stadium holds a maximum of 4,505 people. During the height of their popularity, they sold out 219 consecutive games. How many tickets were sold? Well, if I look at a tape diagram, okay, and it says that the stadium holds 4,505 people, and it says that there was 219 games, and this here is the total people at games. So I can see by this I'm going to have 4,505 times 219. If I use my standard algorithm, I have 9 times 5 is 45. 9 times 0 is 0 and 4. 9 times 5 is 45. 9 times 4 is 36, and 4 is 40. Coming to the tens place, so I'm going to put a placeholder. 1 times 5 is 5. 1 times 0 is 0. 1 times 5 is 5. 1 times 4 is 4. Our last one, we end up at 2 placeholders because this is 200. Then we got 2 times 5 is 10. 2 times 0 is 1 and 1. 2 times 5 is 10. 2 times 4 is 8, and 1 is 9. We add them up, we have 5, 9, 5, 6, 8, 9. So we can say that 986,595 were sold during that time.